Good morning to everyone. Today I am going to present the topic uncontrolled rectifiers. Rectifiers are one of the most important power electronic circuits because they convert AC power into DC power. Since most electronic devices and renewable energy systems require DC power for operation, rectifiers play a vital role in power conversion. In this presentation, we will discuss what these rectifiers, why rectification is needed, different types of uncontrolled rectifiers such as half wave, full wave and bridge rectifiers along with their application advantages and limitations. A rectifier is an electrical circuit that converts alternating current, commonly known as AC, into direct current or DC. AC voltage continuously changes its polarity, whereas DC voltage maintains a constant polarity. Since electronic circuits, battery charging systems, and a DC motor requires DC supply, rectifiers and are used as the first stage in many power electronic systems. Rectifiers are classified into two types: uncontrolled rectifiers and controlled rectifiers. Uncontrolled rectifiers use only diodes as switching devices. Since diodes contact automatically whenever they are forward biased, there is no external control over the output voltage. Therefore, these circuits are called uncontrolled rectifiers. The electrical energy supplied by power stations and distributed through transmission lines is AC in nature because AC can be transmitted efficiently over long distances. However, many electrical and electronic devices require DC power for proper operation. For example, batteries can only be charged using DC voltage. Mobile phones, laptops, computers, and communications equipment also operate on DC power. Industrial equipment such as DC motor drives and control systems requires DC input. Therefore, rectification is an essential process that converts AC power into usable DC power. Without rectifiers, modern electronic system would not function properly. The half-wave rectifier is the simplest type of rectifier circuit. It consists of a single diode connected in series with a load resistor. During the positive half cycle of the AC input voltage, the diode becomes forward biased and allows current to flow through the load. During the negative half cycle, the diode becomes reverse biased and blocks the current. As a result, only the positive half of the input waveform appears across the load. Although the circuit is simple and inexpensive, it utilizes only half of the input signal, which leads to poor efficiency and significant power loss. This slide shows the input and output waveforms of a half-wave rectifier. The input waveform is a complete sinusoidal AC signal containing both positive and negative half cycles. The output waveform contains only the positive half cycles because the diode blocks the negative half cycles. Therefore, the output is not pure DC but a pulsating DC waveform. The advantages of a half-wave rectifiers include simple design, fewer components and low cost. However, it has low efficiency, poor transformer utilization and high ripple content. Due to these drawbacks, it is mainly used in low power application and educational time demonstration. To improve the performance of the half-wave rectifier, the full-wave rectifier is used. This circuit employs two diodes along with a center tapped transformer. During the positive half cycle, diode D1 conducts and supplies current to the load. During the negative half cycle, diode D2 conducts. Even though different diodes conduct during different half cycles, the direction of the current through the load remains the same. This means that both positive and negative half cycle of the AC input are utilized. As a result, the average DC output voltage increases, efficiency improves, and the ripple content decreases compared to the half wave rectifier. Therefore, a full wave rectifier is more suitable for practical power supply applications. Next, we will move on bridge rectifier. The bridge rectifier is one of the most commonly used rectifier circuits in modern electronic equipment. It consists of 4 diodes connected in a bridge configuration. During the positive half cycle of the AC input, one pair of diodes conducts. During the negative half cycle, the other pair of diodes conducts. In both cases, the current flows through the load in the same direction. One major advantage of the bridge circuit is that it does not require a center tap transformer, making the circuit more compact and economical. It also provides better transformer utilization and higher efficiency. Due to these benefits, bridge rectifiers are widely used in battery chargers, power adapters, and electronic power supplies. Uncontrolled rectifiers have a wide range of application in both industrial and domestic sectors. In industries, they are used in DC power supplies, battery charging system, welding machines, electroplating units, and DC motor drives. In consumer electronics, uncontrolled rectifiers are found in mobile chargers, televisions, computers, LED power supplies, and many household appliances. They are also used in renewable energy systems where AC power generated by certain sources must be converted into DC power for storage and utilization. Now let us discuss the advantages and limitations of uncontrolled rectifiers. The major advantages are simple construction, low manufacturing cost, high reliability, and easy maintenance. Since diodes are robust devices, these circuits have a long operating life and require minimal maintenance. However, uncontrolled rectifiers also have certain limitations. The output voltage cannot be adjusted or controlled according to the load requirements. Output contains ripples, which may affect sensitive electronic equipment. Therefore, filters such as capacitor and inductors are often connected to the output to obtain a smoother DC voltage. To summarize, uncontrolled rectifiers are fundamental power electronic circuits used to convert AC power into DC power. We discussed the operation of the half wave rectifier and full wave rectifiers and bridge rectifiers. Among these, the bridge rectifier is the most widely used because of its higher efficiency and better performance. Even though uncontrolled rectifiers cannot regulate the output voltage, they remain essential components in power supplies, battery chargers, industrial systems, and renewable energy applications. Thank you for your attention.